In this video, I'm going to show you how to solve a system of equations with two variables using matrices. So the first thing that you want to do is make sure that the equations are set up in the proper format. So to do that, make sure they look like how I have them here. So if you need to rearrange your equations first to get them where the x and the y are on the same side and it equals the constant, then rearrange your equations. Mine are already set up exactly how I want them. We have the x plus the y equals and then the constant. So it's set up exactly how I want it. So to set this up using matrices, well, we know 2 times the x plus the 9 times the y is going to equal the -1. So we can actually set this up using matrices, and we can split up the coefficients from the variables. So if you think about matrix multiplication, it's this times this plus this times this. So if we're talking about going across the row down the column, so we would have 2 times the x plus 9 times the y. And then that would equal the -1. So then again, if we were going to multiply this times this, what times x plus what times y is going to equal this. So we use the second equation. 4 times the x plus, there's a 1 in front of that y there, 1 times the y equals the 15. So we can set up a matrix multiplication problem that represents this system. So now if we were solving an equation for these variables, we need to get this matrix and move it over, right? So usually if you had something times x equals a number, you would divide it to move it over when you had multiplication, right? So if there's multiplication, you would divide it and you say, hey, x equals 2, I have my answer. Well, with matrices, we don't really divide matrices. It's kind of like if we had like tangent of an angle equals 1. Well, how would we find that angle? Well, we don't divide by tangent. We use what's called the inverse, and we do the tangent inverse of that one. So we kind of do the same thing with the matrices here. Instead of dividing by a matrix, we find the inverse of this matrix, and then we can just multiply by the inverse. So we talked about how to find the inverse of a 2 by 2 matrix in my last video. So I'm just going to go through it pretty quickly. Step 1, find your determinant. 2 times 1 is 2, minus 9 times 4 is 36. 2 minus 36 is -34. So we have to do 1 over -34 times, and then I have to rearrange this matrix. So these two trade places, these two change signs, and then we have to multiply all 4 of these numbers by this here. So the inverse matrix of this 2 by 2 is going to be -1 over 34, because it's times 1, so it stays the same. And then this times this, it would just be 9 over 34. And then this times this would reduce to 2 over 17. And then this times this would reduce to -1 over 17. So we first find the inverse of this 2 by 2 matrix here. Now that we have the inverse of this 2 by 2 matrix, we just multiply it times our solutions here. And if you watched my multiplying video, I like to raise up the second matrix so that way my answer fits nice and neatly right in here. So you can easily see there's 2 rows, 1 column, so there's going to be 2 answers. So we'll have to do -1 over 34 times -1 plus 9 over 34 times 15. So if we type that in the calculator, you should get 4. Then here, start at the front of the row, top of the column, 2 over 17 times -1 plus -1 over 17 times 15. Type that in your calculator, you get -1. So we have that this x over y equals this answer here for -1. So that means the solution to this system has where x equals 4 and y equals -1. And we learned back in Algebra 1 that the solution to a system can be written as an ordered pair for -1, because that's the point where those two equations intersect each other on the graph. So that's it.